All right, this is our lesson on evaluating logarithmic equations. So it starts off with just reminding you of your basic logarithmic rules that we talked about in the previous lesson. So let's just make sure we take a look at those here. We have log base b of y is equal to x if and only if you can rewrite it in exponential form as b to the x power equals y. Log base b of 1 is equal to 0 whenever your argument is 1, it's equal to 0. Log base b of b is 1 if your base and your argument match, that's equal to 1. Log base b of b to the k power is equal to k, because remember that this right here, this right here is 1, and then we have other properties that tells us what to do with that k, but anyways, it's equal to your exponent k, okay? All right, go ahead and pause the video and try this warm up right here, see how you do. Okay, let's see if this works. I tried to do all my work and then change it to white, and now blue. Ooh, look at me. All right, so there's your answers. Okay. All right, so it says here, by the definition of a logarithm, it follows that a logarithmic function g of x is equal to log base b of x is the inverse of the exponential function f of x equals b to the x. So what's important to know here is that logarithmic functions and exponential functions are inverses of each other. So it's just like addition and subtraction, multiplication and division. So how do we undo a log? Exponential form. How do we undo exponential form? Logarithmic form. So it says we can verify these two functions are inverses of each other because both of these are true. So we know that this is a composition that we learned first semester. G of f of x is equal to log base b of b to the x is equal to x, and we know that f of g of x is equal to log base b, no, b to the log base b of x is equal to x. So this says, just to show you that it's true, rewrite this in exponential form. So notice it's log form, we're gonna write it in exponential form. So take your base, bring it to your exponent, which is what your log is equal to, and set that equal to your argument. True, so just verified that. And then this one right here, this is an exponential form, right? Because this is your base, this is your exponent. Rewrite it in logarithmic form. So log, write down your base right there. Your argument's what it's equal to of x is equal to your exponent. This is my exponent. True. So that is proving that it's true. So it says, in other words, exponential functions and logarithmic functions undo each other. They are inverse of each other, okay? All right, so here it says simplify each expression. This is using properties that we learned yesterday, and that is, remember, if the bases match, or actually they're right here also, log base b of b, right, to the x power is just equal to x. And then if you have b to the log base b of x, it's just equal to x. So notice, I like to look at it as if the bases match, that's a base and a base, that's a base and a base. This one would be equal to the exponent, this is equal to the argument. Okay, so here we have 7 to the log base 7. So bases match, it's equal to that argument, 5. Next one, bases don't match, it's a 6 and a 36, but I can rewrite 36 is 6 squared. So now I have base and base match, so it's equal to the exponent, 2. Depending on which form it is, I keep saying exponent or argument, it's depending on what form it's in. All right, this one, the bases do not match, but I can rewrite it so the bases match, because I can rewrite 27 as a base of 3, it's 3 cubed. And then remember, power to a power, you keep your base and multiply your exponents, and then now your bases match. You have log base 3 of 3, so it's equal to your exponent, which is 3x. This one here, your bases match. This is a base of e, and then remember, natural log has a base of e, so it's equal to the argument, which is 2x. And once again, your bases do not match. That's a 10 and 100, but I can rewrite 100 as 10 squared, power to a power, keep your base of 10, multiply your exponents. Your bases now match, so it's 2x. All right, go ahead and pause the video and try these 4 on your, 5, I know how to count, I swear, on your own. I am about to reveal the answer, so if you're not done yet, don't, or pause it, I should say. Nope, worked again. All right, there's your answers. Kind of moved a little bit because that base 10 that I wrote in, the base E that I wrote in are the bases. All right. Next, we're going to talk about finding the inverse of a logarithm. So remember, the inverse of a logarithm is an exponential function. So when you see the directions, find the inverse of each function, and it's a log, the answer is an exponential function. So here are your steps in doing that. To find any inverse, the first step is switch x and y. All right? Then what you're going to do is isolate the logarithm. So we have to make sure we understand what that means. So I wrote 3 logarithms over here. 2 of them are isolated, 1 of them is not. The first one's isolated, the last one's isolated. The second one's not. So if you look at this one, I have x equals log base 2 of y. This one, x equals log base 2 of y plus 2. And I said it really fast because it's like hugged in there. It's like locked in with that parentheses. This is x equals log base 2 of y plus 2. So this is not isolated, okay? You would have to subtract 2 from both sides in this second step. For the first one and the third one, they're already isolated. You keep moving on. Next, you're going to rewrite in exponential form. The inverse of a log is exponential form. Then you need to solve for y if it's not already solved for y. So if y is not by itself yet, get y by itself. It might be like add 2 to both sides, or subtract 6, or divide by 8, or multiply by 7 to get y by itself. All right, I'm going to do 2 with you, and then I'm going to have you try 2 on your own. Okay. All right, so let's go ahead and find the inverse. So we're going to switch x and y. That's x equals log base 4 of x. Oops, of y. Love that for myself. Forgot to switch the x and y. All right, see if your log is isolated. It is. So now I'm going to rewrite in exponential form. So 4 is my base. Whatever my log is equal to is my exponent, is equal to my argument. Now, if y wasn't by itself, like if there was a plus 6 on the end, I would not subtract 6, but y is by itself. So the last thing I have to do is instead of putting y equals, this is the inverse of y. So we write inverse of y like this, y to the negative first equals 4 to the x. So the inverse of log base 4 of x is y equals, or y inverse equals 4 to the x. All right, let's try another one here. Let's switch x and y. X equals natural log of y minus 3, okay? Isolate your log. It's isolated because of that minus 3 being locked in with the parentheses. So now I'm going to rewrite it in exponential form. Remember, on natural log is your base is e, so we're going to do e to the whatever my log is equal to, x is equal to y minus 3. Y is not by itself here, so I'm going to add 3 to both sides. This is not going to the exponent. This is adding it to the e to the x. So I have y inverse is equal to e to the x plus 3. All right, go ahead and pause the video and try the next 2 on your own. Let's see how you did. It's gonna not come up. There we go. Okay. So on the one that you had to do first, the log was not isolated once you switch x and y, so you did have to subtract 7 first, and then you could rewrite it in logarithmic form, or sorry, exponential form. Your base was 10 on that one. On the second one, your log was isolated, but y wasn't by itself once you got it in exponential form. And then you can write it either way. I think it's just easier to put it over 6, but this looks like an exponential function that we graph. So if you wrote it like that, that's great too. All right, next what we're going to do is we are going to evaluate logarithms. So what we mean by that is we're going to give what it's equal to. Like, what is log base 2 of 32 equal to? Okay. So for example, if we wanted to evaluate log base 3 of 81, which is right here, if we wanted to evaluate log base 3 of 1, what you should be asking yourself is asking it to yourself in exponential form. 3 to what power is going to give me 81? All right, so how I end up writing that, what power of 3 will give you 81? Oh, I hate that English. I write it as 3 to what power gives me 81? I see that it's 4, so my answer is 4. And then you can write equals 4, right? Log base 3 of 81 equals 4. All right? Some teachers write an x right here and then say x equals is 4, but I don't like it because there was never an x in the problem, so you shouldn't have x equals 4. All right, so this one's asking us 2 to what power gives me 32? It's the 5th power, so log base 2 of 32 is 5. This is asking me 6 to what power gives me 1/6, right? Or 6 to what power gives me, and then I can rewrite this so it's a base of 6. This is 6 to the negative first power, right? So the answer is -1. Another way of looking at it, you could ask yourself, what would make this 6 drop to the denominator? And that's a negative exponent. It's up to you how you want to see it. This is 2 to what power gives me 5/12. You might have to take a second to think about this, right? Maybe use your fingers to count. So 2 to the first power is 2, squared is 4. We have 8, 16, 32, so that I'm at the 5th power now. 64 is the 6th power, 128 is the 7th power, 256 is the 8th power, so 512 is the 9th power. 3 to what power gives me 1/9, which I can rewrite as 3 to the negative second power, so that's -2. 8 to what power gives me 2. So this one people tend to struggle with, okay? But you can think of it two ways. I think the easier way to say is rewrite 8 as a base of 2. That's 2 cubed, okay? So here, by not putting the x there, to the first power. And not putting the x there, that's what makes it a little confusing. You're solving for what's ever in this box here. So you're solving the equation 3x equals 1. Divide both sides by 3, and you get 1/3. Okay, so in that case, the x works better than my silly box that I put in there, right? Another way of thinking it is, what do I do to 8 to get it to be a 2? You have to cube root. Cube root is a 1/3 power. If it was square root, it'd be a 1/2 power. If it was a 4th root, it'd be a 1/4 power. So there's many ways of thinking this. This is 10 to what power gives me 1,000,000. So 6 zeros, I would need a 6th power. This, I'm just gonna say bases match, this is 7. Bases match, this is n. Bases match, this is 5. I'm not gonna rewrite them. I can just think through those. Next, why is it impossible to evaluate 2 log, I almost said 2 to what power gives me -8, but it's the same thing. Log base 2 of -8. So 2 to what power gives me -8? So think about this. If I bring 2 to a positive power, the number gets bigger, so it's not gonna be negative. If I bring 2 to a negative number, it's gonna turn into a fraction. Like 2 to the negative first is a half. 2 to the negative 1,000,000th is a fraction. It's not a negative number. You're never gonna get a negative number. So this is not possible to evaluate. So our rule here, remember what this is called. This is called an argument. Arguments must be positive. It's kind of a silly thing, like when you get an argument, they're never really positive. But the idea would be if coming out of an argument, you would want something positive to result from it, right? So think of it that way. Arguments must be positive. You can't have any negative numbers there. And you can't have 0, because 2 to what power gives you 0? That's not going to happen either. All right, so arguments must be positive. All right, so here it says, without using a calculator, estimate the value of each log given below between 2 consecutive integers. For example, log base 2 of 11 is between 3 and 4, since 2 cubed is 8 and 2 to the 4th is 16. So you can either give a decimal approximation, which you think it is, or you can say which 2 integers it's in between, okay? It's up to you. I don't care which one you do, to be honest. If we follow the directions, we should be, let's follow the directions. Let's see what 2 integers it's in between. So this is 2 to what power gives me 40, right? So I know 2 to the 5th power is 32, and I know 2 to the 6th power is 64. So I know this is in between 5 and 6, so 5 and 6. That's the 2 integers that it's in between. If you like roughly estimate it, I think it's 5.1 or 5.2. That is fine also. 3 to what power gives me 40? So I know 3 cubed is 27, and 3 to the 4th is 81. So this is in between 3 and 4. 2 to what power gives me 1/3? All right, so I know 2 to the 0th power is 1. It's less than that. So if I go to the negative first, that's a half. And 1/3 is not in between a half and 1. It's less than that, right? So I need to go even farther. 2 to the negative second is a quarter. but a third is in between a quarter and a half. So it's in between -2 and -1. This one, 10 to what power gives me 300, so I know 10 squared is 100, and 10 cubed is 1,000. So this is in between 2 and 3. 10 to what power gives me 3. So I know 10 to the 0 power is 1, and 10 to the first power is 10. So this is somewhere in between 0 and 1. This is 10 to what power is giving me 3/100ths. I need to think of it this way, right? Instead of as a decimal, because I will lose my mind, I think. So I know that 10 to the 0 power is 1. Smaller than that. 10 to the -1 power is 1/10. It's smaller than that. 10 to the -2nd power is 100th. It's 1/100. It's bigger than that, right? So it's in between -2 and -1. And that hurt my brain. Okay. All right, so now what I want you to do is I want you to use your calculator to estimate each value to 3 decimal places and then see how you did with your estimations, which you should be fine, all right? So this is not as straightforward. We're gonna actually learn how to type this in our calculator. Some of the newer calculators have a way of putting logs in your calculator, and you could already start researching how to do that. That's up to you. But I would just use guess and check for now, okay? Because that's not part of this lesson. There's this thing called the change of base rule that I can show you how to put any of these in there. But also, if you see the log button on your calculator, that's common log. We can't use common log. This is log base 2, right? So you could use guess and check. We said that this was in between 5 and 6, so maybe I'll say 5.7, no, it's way too high. And that's not even 5.287, let's say. Okay, let's do 2 to the 5.287 is my guess, right? And I'm at 39. So you just got to get closer, right? So 5.3. Oh my gosh, what is my problem? 2 to the 5.3. There we go. Closer, but not close enough. 2 to the 5.4. Too much, right? So I know it's in between 5.3 and 5.4, and then you can get 2 decimals. So I know it's like a pain in the butt, but go ahead and pause the video, try those, make sure all of your answers from before make sense. Okay, and you can use your calculator to check those, so I'm not doing them. All right, lastly, yes, we have this where it says, what I want you to do, evaluate all of these. So notice A1 and A2 are, I want you to notice something that happens there, do the A1, do A2, and notice oh, these are all properties these all involve properties that we are going to learn in our next lesson. Pause the video, try those. Check your answers here. Oh, also notice on B1 I added parentheses to it because it's supposed to be in parentheses, otherwise it's not showing you anything to do with B2. Style blue. Okay. So you should have gotten that these are all equivalent, A1 is equivalent to A2, B1 is equivalent to B2, C1 is equivalent to C2, so on and so forth. So it's another way of doing these problems, and these are all properties that we are going to learn. So hopefully you're making some connections there. All right, that's it for our lesson on evaluating and inverses.